Okay, so today we're going to be talking about special right triangles, and we're going to be focused on two main questions. The first question is, what is the length of the diagonal of a square? So we've got a square here, so all sides are congruent, and I want to know what this diagonal is. So notice this diagonal creates this right triangle. So if we want to find the third side, the hypotenuse of a right triangle, what do we use? Well, we just use Pythagorean theorem. So let's do that. So if I do 7 squared plus 7 squared equals c squared. So this is like my A, my B, and my C is what we're trying to find. So I'm going to get 7 squared is 49. And then I'm going to add both those 49s together to get 98. So we want to find c, not c squared, so we have to take the square root. So I'm going to get the square root of 98. Now when I type that into my calculator, depending on which calculator you use, if you use our yellow ones, it's going to give me this answer of 7 times the square root of 2, which is about 9.899 as a decimal. Now, if I just wanted to know the decimal, then 9.89 would be great. All right, but I'm really curious about this answer, 7 root 2. So let's look at that for a sec. This is kind of a nice answer because the two values that I started with were 7, and the answer was just 7 times the square root of 2. So I wonder if that will always happen no matter what these sides are. So let's do that. Let's see what happens if instead of 7s, I just have some unknown value. So we'll just call those x, right? And I want to see if my answer always comes out to be x times the square root of 2. So we're going to do the Pythagorean theorem again, but we're going to use x's instead of 7s. So we're going to do x squared plus x squared equals c squared. And I'm going to combine those like terms. So I get 2x squared equals c squared. And remember, we're trying to get c by itself, so we're going to take the square root on both sides. So I'm going to get the square root of 2x squared. Now when I take the square root of 2x squared, I'm taking the square root of both the 2 and the x squared. Okay, so the square root of 2 is just some decimal, and again, I'm not interested in decimals. I want to keep it as the square root of 2. All right, the square root of x squared, well, the square root and the square cancel out, so that just gives me x. So another way we write that is we usually write the x in front of the square root of 2. That way we don't think the x is underneath the square root. So c is, our hypotenuse is x times the square root of 2. So this will always be true for a diagonal of a square. Now the other thing we're interested in is the triangle piece, right? This triangle, what's special about this triangle? Well, if the two sides of a triangle are congruent, we call that isosceles, right? And this is a right triangle. So isosceles right triangles have this special relationship. And the other thing I want us to remember is that if I were to find these two base angles of an isosceles triangle, remember I would just take 180, subtract that 90, and then that would give me 90. And I would take that 90 degrees that's left over and divide it between those two angles. So that's going to give me 45 degrees in that angle and 45 degrees in that other angle. So what we call this is a 45, 45, 90 triangle. So let's summarize that. We've got a 45, 45, 90 triangle. And when we have that, the hypotenuse is always going to be square root of 2 times as long as each of those legs. So whatever those legs are, then the hypotenuse is just going to be that leg times the square root of 2. So you can think of it as hypotenuse equals leg times the square root of 2. So you can think of it as x, if you like axis, x times the square root of 2, or just the leg times the square root of 2. Sometimes it gets confusing to use x because other variables in the problem might mean a different kind of x. So let's do some problems using this special 45, 45, 90 triangle. So in these two triangles, we're going to try to find the length of the hypotenuse. So notice, I have a 45-degree angle here, so that means that this angle has to also be 45. So that tells us it's a 45, 45, 90 triangle. And then I can use this special relationship. So you can see that the leg is 6. So that just means to find the hypotenuse, I just have to multiply the leg times the square root of 2. That's the pattern that we found. So really simply, I know the hypotenuse is 6 times the square root of 2. I didn't need a calculator. I didn't need to do any calculations. So that's kind of the cool thing about finding those patterns is it helps us do problems really quickly. So let's look at this part B. All right, part B, notice that it's a right triangle, and it's an isosceles right triangle because both of these legs are the same. So that means we have a 45, 45, 90 triangle. So we can use this pattern, and all we have to do is take the leg and multiply it by a square root of 2. So if I'm going to do that, then I'm going to do 4 times the square root of 2, that's the leg, and I'm multiplying that by the square root of 2. So don't be intimidated by square root times the square root. All we do is multiply those numbers underneath the square root. So the 4 outside stays the same. But when I multiply 2 times 2, I get 4 underneath the square root. And we all know that the square root of 4 is just 2. So I'm going to change the square root of 4 to just be 2. So all I'm doing is 4 times 2, and that gives me 8. So this hypotenuse right here is simply 8. All right, so don't worry about seeing those square roots. They might look intimidating, but you can do it. Now let's look at another example. In these, we're trying to find the length. They gave us the hypotenuse. All right, so notice again, we have isosceles triangles in both of these. So we know we're dealing with a 45, 45, 90 triangle. And the hypotenuse is 9 times the square root of 2. And remember, we know in our pattern that it's always going to be whatever our leg was, x times the square root of 2. So it's just this number in front of the square root of 2. This one's pretty easy. So I know that if this is 9 times the square root of 2, then x is simply 9. That's what was in front of the square root of 2. So we're going to use that same logic over here. If I notice that my hypotenuse is some number times the square root of 2, then my leg is just that number in front of the square root. So that means that we have x is just 12, because that's the number in front of the square root of 2. Now, in class, we're going to do some harder examples where we're doing more with the square roots. Now, I said we were going to focus on 2 questions, so let's look at the other question. What is the area of an equilateral triangle? All right, so we know area is 1/2 base times height. And if I have an equilateral triangle, all the sides are the same, right? So I just have this equilateral triangle, all the sides are 10. So I know that my base of my triangle would just be 10. But I don't know what my height is. So that's what we're going to focus on here. How do I find that height? So notice that the height, the altitude of an equilateral triangle, it's going to cut this triangle into 2 congruent triangles. So what does that mean? Well, we know in an equilateral triangle, all the angles are 60. All right, this is 60, this is 60, and this whole angle up here is 60. But if I cut it into 2 equal parts, then that angle gets bisected. So that's going to be 30, and that's going to be 30. All right, so these are congruent triangles. And if these are congruent triangles, then this bottom part right here on this triangle is going to be the same as this bottom part. So this bottom side is bisected as well. So I know that 10 is cut in half. So that means that this length is 5 and this length is 5. Okay, so we have 2 congruent triangles, and because we know it's equilateral, it cuts it into 2 equal congruent triangles. I know that this side is 5 right here, so I'm just looking at this triangle over here on the right-hand side. Because I just want to know what the height is. I want to know what this side is. So notice that I have a right triangle. I know 2 sides. I have 5 and 10 are 2 of my sides. So to find that third side, I'm just going to do Pythagorean theorem again. So let's do that. So I'm going to do a squared. I'm going to treat my height as a. So this is my a, and this is my b, and this is my c. So I've got a squared plus 5 squared equals 10 squared. So I'm going to get a squared plus 25 equals 100. And I'm going to subtract the 25, so that gives me a squared equals 75. Now remember, we're trying to solve for a, so I got to take the square root. So I'm going to get the square root of 75. So again, if I do that on my calculator, my yellow calculator is going to give me the answer of 5 root 3, which comes out to be about 8.66. All right, so I know that this height is just 5 times the square root of 3, or 8.66. So if I'm doing that in my area formula, I can now fill in that my height is just the 5 times the square root of 3, which if I multiply all of those together, that gives me 25 times the square root of 3. That's what the yellow calculator would give me. Or if I did it as a decimal, it would be 43.3. All right, so great. We found the area of the triangle. But another interesting question came up. Notice that this height is very well connected to this side right here, this 5 that we found. So if I knew that this was 5, then couldn't I wonder if I could just say this height is always going to be 5 times the square root of 3. So again, I'm going to see if that always happens. So if I just take a triangle that looks like this, okay, so instead of 5, I just have some random value x. And instead of 10, I have double that. Because remember, this 5 was half of that because we split that down the middle. So I'm going to set up the triangle the same way. So I want this hypotenuse to be double of that side. So I want to see, well, will I always get x times the square root of 3? Will that always happen? So that's what we're going to see. So let's do that. I'm going to see, okay, so hold on. We don't know that, so I'll keep that covered. So we're going to do Pythagorean theorem. So my a squared is just going to be this missing side over here. My b squared is going to be the x, and my c is going to be the 2x. So I'm doing a squared plus b squared equals c squared. So x squared is just x squared. But over here, the c squared, I have to square both the 2 and the x. So that gives me 4x squared. And remember, we're trying to find a squared, so I'm going to subtract the x squared over to the other side. So that's going to give me a squared is equal to 3x squared, because 4 minus the 1x squared gives me 3x squared. Now we've got to take the square root of both sides. So if I take the square root, I'm going to get a equals the square root of this whole thing, 3x squared. Now remember, when we took the square root of two things, I have to do the square root of 3 and the square root of x squared. And remember, we said the square root of x squared is simply x. So I'm going to get a is x times the square root of 3. Remember, I don't want the decimal. I want to see a pattern. So this just shows, yes, we do get on this third side, we get x times the square root of 3. That will always happen. So out of this question about the area of an equilateral triangle, we know that when we have this special kind of triangle, notice that in this triangle we have a 30-degree angle, a 60-degree angle, that we have these special relationship between these sides. So let's summarize that. So in our 30, 60, 90 triangle, we know that the hypotenuse is always going to be twice as long as that shortest leg. All right, and then the longer leg, which is across from the 60-degree angle, that's always going to be square root of 3 times as long as the shorter leg. Okay, so the hypotenuse is 2 times the shorter leg, and the longer leg is square root of 3 times the shorter leg. So this is all these relationships are based on that shorter leg. Remember, the shorter leg is across from the shortest angle, or the smallest angle rather. So that's across from the 30-degree angle. So let's do some examples and apply that. So we're trying to find, okay, again, we have this equilateral triangle, 12, 12, and this whole base is 12. We're trying to find the height. So notice that I've got the shorter leg is 6, the hypotenuse is 12. I'm trying to find the longer leg. So according to our pattern, in order to get the longer leg, I just take the shorter leg times the square root of 3. So I'm just going to take the 6 times the square root of 3, and I'm done. I didn't have to do any calculation. Isn't that nice? So over here, I'm going to do the same thing. Now notice that they gave me this is 30 degrees and 60 degrees. So I'm going to say this is my shorter leg, and I'm trying to find the side across from the 60, which is the longer leg. So remember, we're just going to take the shorter leg times square root of 3. So don't let that square root of 3 intimidate you. We're going to do 2 times the square root of 3, that's our shorter leg, times the square root of 3. Now remember, we said all we do is multiply those numbers underneath the square root. So that's going to give me the square root of 9. And we all know that the square root of 9 is just 3. So I'm going to do 2 times 3, and that gives me 6. So this longest leg is just 6. Now I don't know if you notice this, but when I do the square root of 3 times the square root of 3, I always get this perfect square. And that gives me that 3. So it's like the square roots cancel each other out. All right, so let's do some more examples. One more example. And in this example, I am given the longer leg, so I don't know the shorter leg. So I need to find that. Now remember, in order to find that, this square root of 8 part, or this 8 is the same thing as x times the square root of 3. That's the pattern we found for the longer leg. So this is my shorter leg, so this is going to be x times the square root of 3. So if I want to find what x is, I just need to divide by the square root of 3. So that's what we're going to do. We're going to divide by the square root of 3. And it wants us to leave in simple radical form, so we can't just leave it like this. So we're going to do what we call rationalizing the denominator. And here's what that looks like. So I'm going to take my 8 over divided by the square root of 3, and I'm going to multiply the top and bottom by the square root of 3. And you're probably thinking, why in the world would we do that? Well, you'll see why. So when I multiply that in the numerator, I just get 8 times the square root of 3. And the denominator, remember, we get that perfect square, square root of 9. So that's always nice because when I have the square root of 9, that's a perfect square. That's just 3. So I have 8 times the square root of 3 over 3. And now I don't have a square root in the bottom anymore. So when we say simple radical form, we don't want a square root in the denominator. So my x is simply 8 times the square root of 3 divided by 3. So that's what our x is. All right, so that's our simplest radical form. If this was confusing for you, we'll do a lot more practice in class. So don't worry about all that. But let's find the pattern. So now I know what this shorter side is. The shorter side is 8 times the square root of 3 over 3. So remember, if I want the hypotenuse, I just take twice that. I double that. I multiply this by 2. So if I double the 8, 2 times 8 is simply 16. Everything else stay the same because when I double it, I'm just doubling this number in the numerator. So my hypotenuse is 16 times the square root of 3 over 3.